Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions, and here we have to find the domain of this function, that is f of x is equal to cos inverse greatest integer of 2x minus 3 over 5, right? So here we can see that here we have the combination of two important functions. The first one is the inverse cosine function, and the second one is the greatest integer function. So let us see how easily we can find out the domain of this function by using the definition of greatest integer function and some important concept from inverse trigonometric functions. So whenever we have to find the domain of some given function f of x, it implies that we have to find all the valid values of x for which the function is defined. Now here let us first see the inverse trigonometric function, that is cos inverse theta. Now we know that the range of cos inverse theta belongs to this interval, that is from 0 to pi, right? And here this theta must belong to this interval, that is minus 1 to 1. So cos inverse theta, it belongs to this interval, that is 0 to pi, whenever theta belongs to this interval minus 1 to 1. So theta must lie between minus 1 and 1. Now here if we take theta as the greatest integer of 2x minus 3 over 5, then our function, it assumes the form cos inverse theta, right? And here now we'll make use of this inequality, that is theta must belong to this interval, that is minus 1 to 1. So taking theta as greatest integer of 2x minus 3 over 5, over here we have minus 1, and then we have greatest integer of 2x minus 3 over 5, and this is less than or equal to 1. So now we have this important inequality, and we have to solve this inequality to get the values of x. So now to solve this inequality, we have to make use of one important result, which says that if we have this inequality, that is greatest integer of a, that is greater than or equal to minus 1 but less than or equal to plus 1, then this a must belong to this interval, that is minus 1 to 2. So here a should be greater than or equal to minus 1 but less than 2. So we'll make use of this result, right? So here our a may be taken as 2x minus 3 over 5. So here we have minus 1, and here we have 2x minus 3 over 5, and this is less than 2. So 2x minus 3 over 5 should be greater than or equal to minus 1 but less than 2. So now we have a simple inequality and we can easily solve it. So let us first multiply this inequality throughout by 5. So we have minus 1 times 5, and here we have 2x minus 3 over 5 times 5, and here we have 2 times 5. So here we have minus 5, here 5 and 5 get cancelled. We have 2x minus 3, and here we have 10. Now let us add plus 3 throughout. So we have minus 3 plus 3, and here we have 2x minus 3 plus 3, and here we have 10 plus 3. So 3 minus 5 is minus 2, and here we have this 3 and this 3 get cancelled, and we have here 13, right? Now let us divide throughout by 2. So we have minus 2 over 2, then here we have 2x over 2, and here we have 13 over 2. So this 2 and this 2 get cancelled, and here we have simply x, and here we have 13 over 2. So now we can see that our x, which constitutes the domain of this function, this x belongs to this interval, that is from -1 to 13 over 2. And remember, here -1 is included, while 13 over 2 is not included. So this is closed from this end and opens from this end. So now this interval can also be written as -1 to 6.5. So all the values of x which lies in this interval gives us our domain. So let us represent this interval on the real number line. So here we have 0, here we have -1, then we have 1, 2, 3, 4, 5, 6, and here we have 7, right? So 6.5, it lies somewhere here. So here we have 13 over 2, and we can draw a circle here. It implies that 13 over 2 is not included, and here we have -1, right? And here we'll draw a dark circle which suggests that -1 is included, right? So all the values which lies between -1 and 13 over 2, it belongs to the domain of this function. So here we can easily see that -1 is included our domain. So let us take x is equal to -1 in this function. So we have f of -1, that is cos inverse greatest integer of 2 times -1 minus 3 over 5. So here we have cos inverse. This is -2 minus 3 over 5. So this is -5 over 5, that is -1. So here we have greatest integer of -1, and greatest integer of -1 is -1, right? Because the greatest integer of any integer is the integer itself. So here we have cos inverse -1, which is true, because theta belongs to this interval, that is -1 to 1, and here -1 and 1 both are included. So -1, that is x is equal to -1, is in the domain of the function f of x. Similarly, here we can verify that this point, that is 13 over 2, is not included in our domain. So let us find f of 13 over 2. So this is cos inverse, and here we have 2 times 13 over 2 minus 3 over 5. So we can see that 2 and 2 get cancelled, and 13 minus 3 is 10, and we have 10 over 5, that is cos inverse greatest integer of 2. This is 5 times 2, and greatest integer of 2 is 2, and we can see that 2 is not included in this interval. So we have to discard x is equal to 13 by 2 from the domain. So all other points which lies between -1 and 13 by 2 belongs to the domain of this function. So viewers, this is how we can find out the domain of this function, that is cos inverse greatest integer of 2x minus 3 over 5, and the domain is given by this inequality or this interval.